So now let's see what happens when both the source and the observer is moving. So in this particular point, say let's suppose O was your initial point of the observer and S was the initial point of the source. So this was O1. Now after some time, after a time interval of t naught, that is after a time interval of the wave, that is the time period of the wave t naught, we have the velocity of the observer as Vs, velocity of the source as Vs. This is velocity. Now please keep in mind, if you're writing this in an examination, you should properly name all the notations that you have put into. Velocity of, sorry, this is velocity of observer, this is O, velocity of observer and velocity of source, plus we have a different velocity, this is V, that is velocity of sound, velocity of sound. So this is what we know. Now at the time interval of t naught, we have the observer has moved, this is V observer into t naught, the source has moved at a distance of s2. If the initial position was s1, it will move at a distance of s2, and this particular distance is actually equal to V of s, velocity of source, into time t naught. Therefore this time, so after this has happened, so after at time t2, this is n2, the time taken, let the time first, initially the time to reach the source, that is the sound, from the source to the observer was, let this length be L, initial length be L, this was the initial length, this was the initial length. So after this, we know initially the time taken to reach was L upon V. This was the time. This was the time initial. So now, this time, after a time of t naught, the time taken is actually equal to t2, the time, if this is time t1, so the time t2 is actually equal to t naught after a time interval of t naught plus L plus Vs minus Vo. This is the relative speed. Say S is moving and O is moving. So the relative speed is actually equal to Vs minus Vo. So the relative distance that has been traveled in this particular time interval t naught is Vs minus V naught into t naught. So this is the relative distance that has been created. Say suppose V naught is moving, this is Vs minus V naught. Say suppose V naught was moving away, so this will be plus. So the distance will increase. So if Vs is moving along the directions of Vo, then it will remain as negative. So over here, Vs into V naught into t naught will be the relative distance that has been created, and this whole is divided by speed of the sound plus speed of the source or speed of the observer. That is, now here why not we have taken the speed of the observer, or why not we have taken the speed of the source? Why not Vs and why only V naught? This is the question that has been asked. So the relative speed, that is the relative speed, say if a source S is moving when the sound gets away from the source, this Vs is no longer valid. This Vs is no longer valid. What is valid is how Vo is coming towards the velocity of the sound. If this is going in this direction and this is coming in this positive direction, how this two results into V resultant is actually equal to V plus V naught, and therefore the source is moving, and from the source the sound is coming. So the velocity of source in the relative speed between observer and source gets nullified, or it is not required. Only the velocity of the observer and velocity of the sound is required, because as soon as a sound travels, the speed at which the source is traveling is no longer required. So hence divided by V plus V naught. Therefore, we can say that generalizing this at time t equals to n plus 1, we know at time t equals to 2 we had t naught plus L plus Vs minus V naught whole into t naught. This was divided by V plus V observer. Therefore, at time t2, therefore at time t equals to n plus 1, we had n into t naught plus L plus n into Vs minus V naught. In place of t naught, you will have n t naught after a time interval of n plus 1. Therefore, n t naught, this is t naught, divided by V plus V naught. So this is what happens. Hence you can see that in time interval Tn plus 1 minus Tn. So in this two time interval, what we see is n t naught plus, just put over here, just in case of Tn, just put n minus 1 into t naught plus L plus n minus 1 into Vs minus V naught into t naught, and this whole is divided by V plus V naught. So for T2 you have this is for T2 you have n equals to 1. For T2 you have n equals to 1. Therefore for Tn plus 1 you have n equals to 1. Therefore for Tn you will have n equals to n minus 1. So this is what is happening. Please do not get confused. In place of n, if this is T2, you are putting 1. If this is Tn plus 1, you are putting n. If this is Tn, you will put Tn minus 1. So between the time interval of Tn plus 1 minus Tn, just subtract this with this. This is equation 1. If this is equation 1 and if this is equation 2, subtract 1 minus 2, you will have n t naught plus L plus n Vs minus V naught into t naught, and this is whole divided by V plus V naught minus L V plus V naught. This is what we get. So therefore, after solving, we have t equals to t naught 1 plus Vs minus V naught divided by V plus V naught, where V is the velocity of the source, observer, sound of, or speed of sound, and speed of observer. Now this is actually equal to T naught V plus Vs upon V plus V naught. So this is what we get. This is what we have. Therefore, finally, if you look at the frequency, with this expression, I can derive the frequency, and therefore the frequency is given as frequency naught V plus V naught. This is frequency is the inverse of time period. Therefore, V plus V naught upon V plus Vs. So this is the change in frequency. Please keep in mind, this is a change in frequency, that is how the frequency will change when the source when the source as well as the observer are moving. If V naught is traveling in the same direction as the observer, then it will be plus. If it's not, then it will be negative.